I need to go over quickly with 6.3 that I forgot to do yesterday. That's my bad. But let's look at this. So, one is pretty easy. It's just naming sides. It's frozen. So, first it asks to list all three radii, so all the radiuses on here. Someone name me one. AC is one. AD is another. And AB is the other one. Good. So here, here, and here are all radiuses. Now, it says give the segment that represents the diameter of the circle. So what is the diameter? Or the name of the diameter? DC. So the diameter is right here. So what is the relationship between the length of the diameter and the length of the radius? Radius is equal to half the diameter, or if I say it the other way, diameter is what to radius? 2 times the radius. Good. All right. Then it asks to list all the chords that can be drawn on the circle. So there are 2 chords on this circle. What are they? DB and DC. Remember, the diameter is technically considered a chord. Why is AB not a chord? It doesn't what? Right. The endpoints have to be on the circle. AB, it's one of its endpoints is the center, which is technically not on the circle. So the only chords we have is here and here. All right. Finally, triangle DAB. So this triangle right here. It's asking why it is isosceles. So remember, isosceles means 2 congruent sides. So why is that triangle an isosceles triangle? Right, they are congruent. Why though? Right, they're radii. So DA is congruent to AB, and it's because the radii of a circle are congruent. All right. Now, exercise 2 we'll come back to in just a second, but let's look at exercise 3. So now we're talking about major minor arcs. So real quick, minor arc, what defines a minor arc? Right, it's an arc that measures less than 180 degrees. Major arc is what? Right, it's greater than 180. What's it called if it's equal to 180? Semicircle. Good. So, shh. Boys, shh. So it says, name the major and minor arcs that have A, B as their endpoints. So these 2 points are my endpoints. Right, the minor arc is going to be A to B. Remember, we name minor arcs with 2 letters only. BCA, ACB, all right. You name major arcs with 3 letters. So you could have named it ACB. You could have also named it ADB. Remember, that middle letter doesn't matter as long as it is along that arc. But your endpoints do have to be on the ends. Now, they then want us to do the same thing, but with A and C as the midpoints. So now these 2 are the midpoints. So what's the minor arc? AC. What's the major arc? ABC. There's only one way to name that one because B is the only point along that arc. Any questions on naming those 2 arcs? All right. Lastly, central angle. So remember, a central angle is where its vertex is drawn at the center. And what other key feature is true about a central angle? What's true about the measure of a central angle? It's congruent to the intercepted arc. So circle B is shown with various points located on it. They want to know which angle below is a central angle. So let's just go through them all. So DAE, it's this angle right here. Is that a central angle? No. Why? Right. The vertex is not on the center. It's on the circle. There is a special type of angle that we're going to talk about today, but it's not a central. All right. CBA. So CBA. Is that a central angle? Yes. So that's probably our answer, but we'll come back. All right. Let's check the other ones just to be safe. So CEB. Is that a central? Nope. Vertex isn't at the center. One of its endpoints is, but not the vertex. And then ACB. What about that one? Nope. Same thing. Vertex is not at the center. So the vertex has to be the center, not just any points. So 3 is your answer. So on that note, let's look at 5. So they told us that the central angle ADB is 112 degrees. They wanted to know what is the measure of arc AB. What would be the measure of arc AB? It's 112. Why? Boys. It's the intercepted arc to the angle. You can think about it as the ice cream on top of the cone. If the angle's the cone, the arc is the ice cream. So this would be 112 degrees. Now, on the flip side, how can I use that little piece of information to find the major arc ACB? Right, you would do 360 minus 112, which would be what? 248. Good. Yeah. Now, let's go back to exercise 2. This is the main one I wanted to go over because you may see a question like this. So, in circle M, point A is located on the circle such that AM is 2x plus 7, and if the diameter of M is 74 units long, what is the value of x? So, let's actually draw the circle that it's talking about. So we have some circle, and it is called circle M. So the center point is M. They say that point A is located on the circle, and the segment AM is 2x plus 7. They then said that the diameter of the circle, so just some random diameter, all right, is 74 units. So the entire diameter is 74 units long. And they want us to solve for x. So first off, what is AM? What type of segment is it? It's the radius. So let's think about this logically. How could I set up this equation to solve for x using the pieces of information that I know? 2x plus 7 is what? It's not equal to 74. Because 74 represents the what? The diameter. So if a radius and the diameter are not congruent, but not square root, but all right, so you could either divide the 74 by 2 or you could double this equation. So 2 ways you could set it up. You can either set it up as 2 times 2x plus 7 is equal to 74, or you could set it up as 2x plus 7 is equal to 74 divided by 2. Either way. All right. But this one's not too bad because they actually gave you a whole number for the diameter. All right, so whichever one we solve, it doesn't matter. You should get the same thing. So I'm going to solve the left one first. So if I do 74 divided by 2, what is it? No, it's an even number, so it should be nice. You guys got a calculator in front of you? It's 37. That's a nice whole number. It's no decimals. I said it's a nice number. So what do I do next? Subtract 7 from both sides. 2x is equal to 30. Yep. X is equal to 15. Now, let's say I solve the other one. What would you do first? So distribute, yeah. So 4x plus what? Is equal to 74. Good. 4x is equal to 60. Divide by 4. X is still equal to 15. So regardless of which way you set it up, you do get the exact same answer. So the biggest thing that you had to know was that the radius is half the diameter, or that the diameter is twice the radius. That's what you had to know for that problem. All right. Any questions on that stuff? All right, so let's actually talk about what we are going to do today. So that wraps up 6.3. I will note that you do have a quizzes for 6.3 as well. It's already assigned to you. But we need to go ahead and get into 6.4. All right. No, it'd be next week at the best, at the latest. So 6.4. All right. You need your journal out. We're going back to your foldables. So we're doing the next foldable on the list, which looks like this. 6.4, number 1. It should have 4 theorems on the front and circle with some angles. If you're going through like the order, it should be the third in the order. Now, the thing about circles is that angles drawn within circles actually have special properties depending on how they're drawn. So the first angle that we learned about was a central angle, meaning that its vertex is at the center. That's its kind of defining quality. And the property that is true about it is that it is congruent to its intercepting arc. Well, we're going to talk about some other types of angles today on circles. So the first type we're going to talk about is the inscribed angle. So if an angle is inscribed in the circle, so it's an inscribed angle, that's the actual name for it. All right. Feature about it is that the measure of the angle is half the measure of the intercepted arc. So, also a defining feature about the inscribed angle, all 3 points are on the circle. Or if you even want to get into more detail with it, the vertex is on the circle. So all 3 points are on the circle. That's typically true. Sometimes there's like maybe 1 point that's not, but that's okay. But the vertex has to be on the circle. That's the big key there. The vertex is on the circle itself. So if we look at this picture here, If you notice, all 3 points, including the vertex, are on the circle. So this right here is the inscribed angle. Now, the connection is that this angle is equal to half the measure of its intercepting arc, which is right here. So for example, if this angle was 30 degrees, that would make this arc what? Say it one more time. Backwards. 60. So the arc's going to be bigger than the angle. The angle's half the arc. So let's say we actually name this angle. Let's name it ABC. We would say that angle ABC is equal to 1/2 of arc AC. Which means on the flip side, arc AC is equal to twice angle ABC. So look on the inside of your foldable. Let's look at those first 2 problems. If you guys need it, don't forget there's always the OneNote as well. It updates as I write it. No, you're good. I'm just saying that like if you want to have that up, you can. All right, so let's look at example 1. So it says arc BC is 120. So this arc right here is 120 degrees. And it wants us to find the value of x. So x is this angle right here. So let's kind of logic our way through this. What would be kind of an important thing that I need to know to find that angle measure? What do I need to know to find that angle measure? So how did like the formula that I just gave you previously help us find that angle measure? First off, is the 120 the intercepted arc of angle x? Is it the ice cream on top of that cone? No, it's not. But I can find that intercepted arc, can't I? How? It's part of a semicircle because what is AC? It's a diameter. So that means this is 180 degrees. So how would I find arc AB? How would I find arc AB? Right, we would subtract 120 from 180, which would be what? 60 degrees. So this arc is 60 degrees. So if the arc is 60 degrees, what's the measure of the angle? It's what? It's 30. You would take 60 and divide it by 2. So it would be 30 degrees. Does everyone understand how I did that? So again, knowing what those key features of a circle are called and what properties they hold is important. You had to recognize that AC was the diameter because it's 2 endpoints and it's clearly going through the center of the circle, which means that on either side of it, it would be 180 degrees. Any questions on number 1? All right, let's look at 2. So they said that this angle right here is 86 degrees. They then said that this arc is equal to 1/3 times 9x plus 3 degrees. And they want us to solve for x. So first off, we know what the angle measure is equal to. So can't we figure out what the arc is equal to without having to solve for x or anything? Can't we do that? Yeah. What's the only thing we got to do to find that arc? You just multiply 86 times 2, which is what? Good. All right. So this arc is equal to 172 degrees. So what do you think I'm going to do to solve for x? Set it equal to 172. So I have 1/3 9x plus 3 is equal to 172. So what do I do first? Distribute the 1/3. Now remember, multiplying by 1/3 is the same thing as doing what? Dividing by 3. So if I divide 9x by 3, what do I get? 3x. If I divide 3 by 3, what do I get? 1. So then I'm going to subtract the 1. 3x is equal to 171. Then what do I do? Divide by 3. X is equal to what? Guys, if you don't have a calculator, go grab one. 57. Now, since it's not an angle measure, we'll keep it at just 57. You don't need to put degrees. Okay, take a minute. If you don't have a calculator, go grab one right now before I move on. Even if I don't put it on the board, always assume that you're going to need a calculator in this class. All right, so those are the basic inscribed angles. But let's look at some other ways that we see inscribed angles. So go back to the front. Let's look at theorem 2. So if we have two inscribed angles of a circle or congruent circles that intercept congruent arcs or the same arc, then the angles are congruent. So the same property remains. It's still half the intercepted arc. But let's look at these two angles here. So the angles that they're talking about, these are the intercepted arcs. So right here and right here. These are the two intercepted arcs. Now, or inscribed angles, sorry. But they do intercept the same arc. You guys see how they both have the same ice cream? All right, so because of that, we can say that these two angles are congruent. Now, let me use a darker color. So if I actually name these, let's call this one A, B, C, and this one A, D, C. So that means that angle ABC is congruent to angle ADC. And since they share arc AC, that means that they are both half of that arc. So AC would be equal to twice ABC or twice ADC. All right, so let's go back to the problems on the other page. Let's look at 3 and 4. So it says the measure of ST is 72 degrees. So ST is this arc right here. It's a minor arc, and it's 72 degrees. And it wants to find the measure of angle 1 and angle 2. So here is angle 1, and here is angle 2. What's going to be true about those two angles? They're going to be congruent. So angle 1 is going to be congruent to angle 2 because they intercept the same arc. Now, how do I actually find those two angle measures? What do we know about inscribed angles? What did we just say about them in the previous theorem? They're half the arc measure. So how do I find angle 1 and 2? I do what? Not multiply by 2. We're going to divide by 2 because the arc is going to be the bigger of the two. So we're going to do 72 divided by 2, which would be what? 36 degrees. So these little angles here are both 36 degrees. Any questions on number 3? All right. Let's look at 4. So it wants us to find the measure of angles 1 and 2. So here's angles 1, and this is angle 2. What's going to be true about angle 1 and angle 2? They're going to be congruent to each other because they share this same arc here. Now, so something that we need to note, all right, let's kind of figure out a plan of attack. So we know angle 1 is going to be congruent to angle 2. All right, but we can't find those angle measures until we can find what this arc measures. So what else do you see in this picture besides the other two arcs labeled? What's congruent? Do you guys see these little tick marks right here? So another thing about circles is if two chords are congruent, all right, that means that the arc that they form, so this arc and this arc, are also congruent. So what do you think this arc's going to be? 125. So now do I have enough information to find the last arc? Yeah, how? Right, you subtract all three of those from 360. So 360 minus 125 plus 125 plus 55. What's that equal to? $55. So, I mean, it's clearly not drawn to scale, but that's 55 degrees. So, how do I find angles 1 and 2? We know they're equal to each other, but how do I use that little tidbit of information to find it? You divide them by 2. So we're going to do 55 divided by 2, which will be what? 27.5 degrees. So that's the measure of both of these angles. Any questions on 4? Okay, let's go back to our theorems on the front. If an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. Why does that make sense? So if an inscribed angle, which we know is half its intercepted arc, intercepts a semicircle, its angle is 90 degrees or a right angle. Why is that true? So look at this angle right here. It's clearly intersecting a semicircle because its two endpoints are on the diameter. So that means that this angle measure is a right angle or 90 degrees. Why is that true? What's the connection between the intercepted arc and the inscribed angle? It's what? We've been saying it like this entire lesson. It's half the angle's half the arc. So why is it that if we intersect a semicircle, we get a 90-degree angle? Right, because a semicircle is 180 degrees. And if we divide 180 by 2, what do we get? 90. That's why that's true. All right, so let's look at number 5. So we should not really have to do any legwork for number 5. What's the answer to x? 90 degrees. Because if you look, this angle, it's intersecting that semicircle, which we know that semicircle is 180. 180 divided by 2, x equals 90. Now, let's look at this one. So they want us to find the value of x. All right. So they have these two angles right here. And then if you look, this inscribed angle right here would be what? 90, because it's intercepting that semicircle. Now, this question actually doesn't deal with circles. The only part of the circle that you really needed was the fact that it was one of the angles was intercepting a semicircle. Besides that, we're actually looking more at triangles. So if we look at this shape right here, that's a triangle, right? What do we know about triangle angles? They add up to 180. So how do you think I'm going to solve for x? Right. We're going to add them all up, set it equal to 180. Because all the triangle theorems still hold. All three angles of a triangle should still add up to 180. That doesn't change just because it's in a circle. So, combine like terms, I get 6x plus 96 is equal to 180. I'm going to subtract 96. I get 6x is equal to what? $84. And then divide by 6. X is equal to 14. So guys, sometimes knowing the property is only half the process. Knowing the property will lead you to how you solve for the answer, but you still got to use a little bit of logic with it. You had to notice that that was a triangle and that you can set that equal to 180 because it was a triangle. Yes, ma'am. Just stretching. Okay. All right. Last theorem on this foldable. So, if a quadrilateral is inscribed in a circle, meaning all 4 vertices of the quadrilateral are on the circle, The opposite angles are supplementary. So we had a whole unit on the last unit about quadrilaterals. This is an inscribed quadrilateral. It's not a special type of quadrilateral like a parallelogram or a rhombus or whatever. It's just a quadrilateral. But if they are inscribed in the circle, then they are supplementary to each other. All right. That does not necessarily mean that the consecutive angles are congruent. It just means that the opposite angles are supplementary. And what does supplementary mean? They add to 180. So let's look at this. Let's look at this right here. Let's call this quadrilateral ABCD. Someone name me one pair of opposite angles. B and D. So B and D. So that means that angle B plus angle D is equal to 180 degrees. What's the other set? A and C. So A and C. So angle A plus angle C is equal to 180 degrees. Now, notice how I marked them all as different measures. That's because we're not guaranteed to know if they are the same measure or not. So I'm not going to assume. All right, so let's do that last little bit of problems on this foldable. So they want us to find the values of x and y. How can I find x? I do what? So what's the connection between these two angles? They're what? No. What did we just say on the previous page? They're supplementary. So they add to 180. So what's the only thing I really got to do to solve for x? 180 minus 55, and that'll give me x. And x in this case equals what? It's what? 125 degrees. So x is equal to 125 degrees. Now, to find y, what's the connection between 70 and y? They're also supplementary. So that means I would do the same thing. I would subtract 70 from 180 to get y. So y would equal what? 110. Now remember, all four angles of the quadrilateral should still add up to what? 360. All right. So that's a way you can check yourself. Add up all the angles, make sure it equals 360. All right, last one for this foldable. They want us to solve for x. So notice these two angles, what's the relationship? They're what? Y. They're opposite each other in the circle, so they're supplementary. So how would I set up an equation to solve for x? Good. So add them together, set equal to 180. So I'm going to combine like terms. So 5x and x becomes 6x. I'll subtract the 24. 6x is equal to what? 156. And I'm going to divide both sides by 6. Shh. So it's 26. Any questions on inscribed angles? So the big takeaway from inscribed angles overall, if there's one thing you need to take away from inscribed angles, it's that inscribed angles are half their intercepted arc. That's the big takeaway. Inscribed angles are half their intercepted arc. Any questions on inscribed angles? All right, so now flip to the next foldable. This is the last one we'll do today. So the last little bit about angles that we need to talk about are angles formed by secants and tangents. Now, we talked about secants and tangents yesterday. Can someone tell me what a tangent is when it comes to a circle? What is a tangent? So it's a line that touches the circle at how many points? 1. So it touches the circle at 1 point, but it does not go through the circle. What's a secant? You're close. It's a line that goes through the circle, hits at 2 points. So a secant is the line that goes through the circle and it hits at 2 points. It intersects at 2 points. All right. So the first theorem is this top one right here. So if a secant and tangent intersect at the point of tangency, the point of tangency is basically the only point that the tangent line hits the circle on. So it's the point the tangent hits the circle. All right, so it's the point that the tangent line hits the circle at. That's what the point of tangency is. Then the measure of each angle formed is half the measure of the intercepted arc. What does that sound like to you? Half the measure of its intercepted arc. What does that sound like to you? Inscribed angle, and that's exactly what this is. This is just another type of inscribed angle. So let's look at it. Now, this inscribed angle is a little funky because instead of one of its sides being in the circle, it's actually part of the tangent line. So this is the secant that they're talking about. This is the tangent. Specifically, this point is the point of tangency. This is the angle of which they speak. And then the arc is typically formed between these 2 points. And they're saying that whatever the angle of the circle is, it's going to be half that intercepted arc. So if I said this angle was 30 degrees, what's this arc? 60 degrees. So another way you can also say it is that the arc is equal to twice the angle. So the arc is equal to twice the angle. Actually, let me write out the word arc. So the arc is equal to twice the angle. All right, let's look at a problem with that. So let's look at example 1 on the inside. So it says to find the value of x given this scenario. So they're saying that this angle is 89 degrees. And that this arc is equal to this expression. So we kind of already did this with an inscribed angle. Can't I already figure out what the measure of the arc is without actually having to solve for x? Yes, no, maybe. Yes, you can. How? I do what? 89 times 2. So this arc is equal to 89 times 2, which is what? 178 degrees. So this arc is 178 degrees. How can I use that little tidbit of information to set up my equation? Right, 1/2 times 22x plus 4 is equal to 178. That's exactly what that expression should be equal to. What's my first step to solve? Distribute the 1/2. And remember, multiplying by 1/2 is the same thing as doing what? Dividing by 2. So what does 22x become? 11x. What does 4 become? 2. It's equal to 178. I then subtract the 2. 11x is equal to 176. And then I divide by 11. X is equal to what? 16. Put it up. Also, guys, come on, get with it. This side of the room is carrying y'all. All right, so that's just an inscribed angle. Let's look at another type. So now we're kind of breaking away from the inscribed. And we're going to look at this one right here. Now, it states that if two secants intersect in the interior of the circle, what does interior mean? Inside. Then the measure of the angle formed is half the sum of the measure of the arcs intercepted by the angle and its vertical angle. That's a mouthful, but it just chalks down to this. The angle inside is equal to half the first intercepted arc plus half the second. Or plus the second, or the sum of the two. So, first off, let's just name these two angles. Now, these two angles would be congruent. Why? They're a specific type of angle, not one that we've talked, that you guys have heard before. Starts with a V. They're vertical. So, vertical angles are still congruent. All right? So, since they're vertical, they're congruent, but their arcs aren't necessarily going to be congruent. The only time they're congruent is if they were both inscribed inscribed angles, or if they were both central angles and they happen to be congruent. So, now, let's call this A, B, C, and D, and then this point right here is E. So all it's saying is that the measure of angle AED would be equal to the measure of arc AD plus the measure of arc BC, all divided by 2. All right. And that means that BEC would be the same thing because these angles are congruent. So those angles are congruent so that they both equal the same thing. So regardless of what these arc measures are, if we add them up and divide by 2, that would give us those 2 red angles on the inside. So let's say, for example, that this arc AD was, let's say it was 70 degrees, and arc BC was 40 degrees. How would I find those 2 angle measures? Right, you just do 70 plus 40 and then divide it by 2. Make sure you do the 70 and 40 first. So that would be 110 divided by 2. So what's the measure of both those angles? 55 degrees. So this would be 55 degrees. This would be 55 degrees. Now, this special subtype of angle is called a bow tie. Because if you look, it kind of looks like a bow tie. If you like actually drew across the lines that made the angles in the arc. You guys see the bow tie? If you can't see it, it's like right here. See the bow tie? It's a lopsided bow tie, but it's a bow tie. All right. So let's go to example 2 on the inside. So it wants to know what the value of x is. So what should I do to find x? 85 plus 35 and then divide it by 2. So what's 85 plus 35? 120. We divide that by 2. What's the measure of angle x? 60 degrees. So x is equal to 60 degrees, which means this angle would also be what? 60 degrees. So the reason I'm telling you all these like special names like inscribed and bow tie is because that's how you can recognize which property to use based off of the general shape that you see. Now, the last theorem is, there's a couple of combinations for this one. If you have 2 secants or a secant and a tangent or 2 tangents that intersect in the exterior of a circle. What does exterior mean? Outside. Then the measure of the angle formed is half the difference of the measures of the intercepted arcs. So, this picture right here is formed by what type of lines? Is it tangent or secant? These are both double tangents, so this is a 2 tangent one. Now, just so you know, the other way you could see this picture is you could see it as 2 secants. So it looks like that. So that's 2 secants. If I could spell secant correctly. You could also see it as a combination of a tangent and a secant. So here's the tangent, and there's the secant. I drew that line too long. So that's the other way you could see it. So that is a tangent and a secant. Now, how it works is that I call this the big scoop of ice cream. All right? Because you got to figure out which one is the major arc and which one is the minor arc formed by those angles. And the way you figure it out is is that the minor arc will be the bottom scoop of ice cream. The bottom of the scoop. So this would be your minor arc. Your major will always be the top of the ice cream. So this is your major. So same thing over here. Your minor is the bottom of your ice cream cone. Your major is the top of the ice cream cone. So this one, your minor, still the bottom. Your major is still the top. Crap. Now, regardless of the configuration, whether it's 2 tangent, 2 secant, or a tangent and a secant, the rule is still the same. It is still the outside angle. So this angle right here. So this is for all of these. That outside angle is equal to the measure of the major arc minus the measure of the minor arc, and then you divide it by 2. So again, this is the angle which you're trying to find. It's the angle that's formed outside of the circle. Now, this configuration also has a special name, like the other two. We call this one a beak. Like, the beak of a bird. Because if you think about it, there's your bird. All right. This is a bird with a funky eye. This is a bird with, I don't know, a goiter or something. All right. So we call those beaks. So let's actually look at some problems like that. So look at this one. Now, this one is a tangent secant combo. Still a beak though. Now, it says to find the value of x. All right. X is this angle right here. Now, they said that the measure of this arc is 4x plus 5, and the measure of this arc is 50. Of those two arcs, in relation to that angle, which one's the major, which one's the minor? Right, the major is the red one, or I guess it's pink on my end. The minor is the green, because that's the bottom of the cone, that's the top of the cone. So, to set up my equation, all right, we're literally just going to plug all the pieces that we got into the formula. So the angle x plus 25 is equal to the sum, not the sum, the measure of the major arc, which is 4x plus 5, minus the measure of the minor arc, which is 50, all over 2. Now, that is not a necessarily hard equation, because how do I get rid of the dividing by 2 in the bottom? Multiply both sides by 2. So this is now 2 times x plus 25 is equal to 4x plus 5 minus 50. And that's a pretty straightforward equation. So don't let that dividing by 2 throw you. All you got to do is just multiply both sides by 2. All right? So I'm going to distribute on this side and combine like terms on the other side. So this will be 2x plus 50 is equal to 4x minus 45. What do I do next? Yep. So we can subtract the 2x over, add 45 over to the other side. This would be 95 is equal to 6x. Now, if I divide by 6, what do I got? Oh, it'd help if I actually did the math correctly. It's 2. I guess in my head I added. It's what? 0.5? Good. So x is equal to 47.5. All right. Now let's throw it all together. So last problem, and then we're done for the day. So this is kind of a combination of all three, or like everything we kind of learned today. So my recommendation is always mark what they give you. All right. So in quadrilateral NEWL, or NEWL, it's inscribed in the circle K. So that means what we learned about inscribed quadrilaterals in the previous foldable applies here. TR is the tangent to circle K at E. So that's the point of tangency. The measure of angle NLW is 78, and the measure of angle 46, the measure of arc EN is 46. They also said that segment LN is congruent to WE. So we're going to go through and mark all that they just said. So NLW, so this angle right here is 78. All right. EN, so this arc right here is 46. And then they also said that segments LN and EW or WE are congruent. So now we're going to go through and find the missing arcs and angle measures that they want. Now, we're probably going to go out of order because some are easier to find than others, and you need some of the others in order to get, the others. So I would say finding measure of TEN is going to be easy. So we're going to find the measure of TEN, which is this angle right here. How can I find TEN? What type of angle is that on the circle? Is it inscribed, a bow tie, or a beak? Nope. It's inscribed. All right. The angle itself is technically not outside the circle because the vertex is on the circle. So this is an inscribed angle. So what's the connection? How do I find it? It's inscribed. Half of the arc, what's the arc? 46. So to find, I'm going to do 46 divided by 2, which will be what? 23. So this angle is 23 degrees. Now, let's find WEN. So this angle right here. Now, this angle, how we're going to find it, is going to come from the previous foldable. So think about it. What on this picture can help me find that orange angle? Right. These two angles are opposite each other, and they're inscribed in the circle, meaning that they're supplementary, so they'll equal 180. So we're going to do 180 minus 78. And that'll give me what? It's what? 102 degrees. So this angle is 102 degrees. Now, another thing to note is arc EW. So this arc right here. Now, this one's going to take a little thinking. So, how I would look at it is that it's kind of a piece of a whole. All right. So, if we think about this carefully, all right. Do you guys see a bigger scoop of ice cream that EW may be a part of that's connected to a cone with an angle? So I'm thinking the arc WN is going to be pretty easy to find. Why? What angle is it intersecting? It's intersecting the what? The 78. So it's intersecting 78. So how would I find it, ladies? It's an inscribed angle. We got the angle. How do I get the arc? Multiply it by 2. So 78 times 2, which is what? Good. So that entire green arc is 156 degrees. So now can I find EW? How? 156 minus 46. So we can do 156 minus 46. Oops. Which is what? 110 degrees. So this is 110 degrees. And then that leads us to our last angle, which is WER. So what's WER? How do I find it? How'd you know? It's technically not vertical. It'd be half of what? It'll be half of 110 because it's another inscribed angle, but it's one formed by a tangent. So I'm going to do 110 divided by 2, which that should be 55. Does everyone understand how to find these angles and everything? So I know it's a lot. We'll do some more practice with this either tomorrow or Monday. I haven't really decided what I'm doing for the half day tomorrow. All right. Nope. I don't know. All right. Anyway, so you do have a new Delta Math for 6.4. Don't forget there's also a quizzes for 6.3.